And for the next section here, I'm going to actually move into Creo. Now, I'm using Creo here. You could actually use any of the major CAD packages to repeat what I'm going to show here. What we're going to do is we're going to push this geometry that we see here. This is a pipe assembly into Ansys. So I'm going to click this workbench button over here. And while that's doing its thing, I will show you a couple of the main parameters that are in play here. So this will eventually be a CFD study. So we'll have flow coming in from here. This will be a cold inlet, be a hot inlet on the top. There'll be a flow restriction, which is kind of this face that you see just on the inside here. And then this will be the outlet. Right, so the geometry is transferred to Workbench. I'll ask it to open, and I'll just continue showing you what we're going to modify here. So the way that the Creo works is you can make parameters of anything that basically carries a number. So for example, this sketch 3 here, we click this dimension button here, you can see that we've got a 40 diameter here, and that's a restriction that's in place. If I click that, you can see it has a value and a name, right? So there's a name here, DS pipe restriction. There are other parameters as well. I think there is one that was also nominated here where we could have extended this outlet length here. So this height is nominated, but basically anything that had a dimension originally attached to it, you can now transfer directly into SpaceClaim. If you are a user of SpaceClaim, you might notice that we have this block recording showing up on the right side. So with this Workbench project, I'm just going to save this somewhere on my desktop, and then we'll show you some parameter modifications. The parameters that were in Creo have actually shown up here now as well. Right, so I've got these exit heights. The restrictions the one I want to play with and show you, so I'm going to nominate that here. And because it's inside the geometry, what I'll do is I'll just grab this geometry here and I will say make transparent. Now what you might have noticed if you're watching the right side there was that step was recorded. We're going to come back to that. So this restriction right now is set to 40. So this is a parameter that we can look to modify, and if we replay, you can see the lightning bolts have shown up here. What we're doing with this 60 now is we're actually sending this 60 back to Creo. We're telling it to rebuild the model there, and it's coming back in to SpaceClaim. So just to show you, it's still 40. As I click the mouse, you'll see it's changed to 60. So the motivation here is people that want to modify their original CAD. They don't want to do the modification in SpaceClaim. They'd like to find an optimal design and keep it in their original system. This is now the building block to allow you to do that. I'm just going to add a few things quickly here. I want to maybe prepare this simulation for CFD now. So again, I'll just show volume extract, go a bit faster this time, pick my inside face here. And the create volume is recorded. Now at this point, I don't really need the other material, so I'm going to say hide other. Next step is we might nominate this restriction face, and we might say, well, let's just give that a color. So I'll show you how that's done. This could be if you're passing the geometry down the line and you're saying, look, this is the face of interest. This is the one that we're going to modify. As far as CFD goes, common thing we might want to do is clean this model up. Now it's quite clean. We've got very little, I think, to clean up. There's an extra edge there. But one thing we could do certainly for meshing purposes is we could split the model and include a symmetry plane. So I'll go back to my design tab. and add this plane in here, then we can do a split body on this solid. And you can see everything I do here is being recorded as well. Now, next steps for CFD analysis would be to maybe name some regions. So we'll tag up an inlet or an outlet perhaps. I'll just do a couple. Let's do this cold inlet here. So that's the cold inlet, and I'll tag the symmetry as well. Now, at this point, everything that we've done up to these blocks is something we can actually edit the parameters for. So this is very much a parametric sequence of what we've done to this point. So for example, where we've got set color here, we've got a selection which was attached to this original face. But if I just happen to click this arrow, then the tree winds all the way back to this operation. And I might say, well, we'll move that tag over to the inlet, let's say, just to show you how that works. And then if I want to rebuild just this one step, I can say move to, right, to rebuild this current step. So I've now moved my color coding over to the inlet. Since I'm here, I might say, well, I want to tag the hot inlet as well. Let's give that a red color so people can see what that's doing. And we've actually injected that command upstream of everything else, right? So moving up to these areas, modifying, you can suppress these operations as well. So this would suppress the green, but not the red. And then this option here just tells it to play from end to end. So you'll see the various operations that happen in sequence. The green coloring is suppressed. You can see it's gone from here, it's gone from there, and we're left with red. So the other thing you can do with these is you can drag these blocks around, right? So you might decide just to move that one before the previous one, and you can get these different steps to all replay in sequence from there. So I think the takeaway I've noticed from this is that perhaps it's taken a while for SpaceClaim to be able to implement all this stuff, but the way they've done this seems to be fairly robust. It seems to be flexible. It allows you to drag things around, modify things, and replay things in sequence, right? So it's possible to break things. Certainly, you could certainly put things out of order, but it's been a pretty robust tool in the way that we've been testing it so far. Just show you one thing downstream of this, because obviously what you might then do with this is you could push this into Fluent. So this is kind of how your workflow would look. So your geometry would go into a Fluent session and into a solution. And I'll just open one that was pre-solved, because you can also parameterize, as you'll well know in Fluent, you can pick parameters out from the physics side. There's an example just we ran as a quick test, and this was changing the pipe restriction. So you've got 60 mils, 50, 40, 30, 20. And then we also ran a fixed pipe restriction with a varying inlet speed for the cold flow, right? So the cold flow was coming in fast, gradually reducing down to 1. And then you can plot these charts, standard workbench stuff. You can see here is the cold inlet speed increased, the outlet temperature decreased. And of course, all of this then leads into being able to do things like response surface-based optimizations and things like that. So that's one example from the CFD side that you can use.